One thing I just quickly, we're transitioning now to some presentations that are, we're focused kind of on energy and state level policy, and now we'll be transitioning to topics that deal more directly with community health and the energy transition. And some of these projects are going to deal with the topic of public health. And just really quickly want to say that the impact of extreme weather and extreme heat on the human body, I'm saying this right now, in 2025, what we're about to see, what we're seeing, this climate change thing, I wouldn't be surprised if in 15 or 20 years, the words heat event and human heat exposure come before climate change in the public consciousness and the media. The human body cannot tolerate wet bulb temperatures above a certain level. There will be substantial disruption and displacement, and it's likely too late to mitigate, to avoid a lot of that in places like North India and in places near the Persian Gulf, even in parts of the United States, some of the poorest, most vulnerable parts of the United States. And higher temperatures are also often associated with situations where you have large populations and difficult topographies, and all of that population in a small place, exacerbated by the kind of photochemistry we get with high temperatures, leads to very difficult air quality conditions. The next presenter, Sharan's project, takes on, in public health, you have to find data and then make attributions and think about a lot of things, right? Often you're not trying to identify causal first principles mechanisms, but you're trying to establish relationships that exist between the trying to sample you have and the overall population to try to provide policymakers and society with more information about how to avoid some of these terrible impacts of heat and other things. So, and air quality. And Sharan did a project that deals with preterm birth, which impacts a lot of people, and a lot of people will spend a lifetime trying to deal with the impacts of a preterm birth. Sharan's presentation, Spatially Varying Contribution of PM2.5 on preterm birth, racial and ethnic inequalities in California. Sharan, the floor is yours.
All right, good morning, everyone. Let's see if this works. All right. Hi, everyone. My name is Sharan. When I entered this program, I wanted to study not just how anthropogenic emissions impact the climate, but also our human bodies for generations. So my project explores just that, and it's entitled Spatially Varying Contributions of PM2.5 on Preterm Birth, Racial Ethnic Inequalities in California. So I'm going to start off with a little bit of background, give you some introductory definitions and an outline of my project, and so hopefully you'll be able to follow along. So just as an introduction, preterm birth is defined as less than 37 weeks of gestation, and it holds lifelong implications for the fetus. For the babies that do survive, there's health effects including neurophysical disorders, cerebral palsy, autism spectrum disorder, and other developmental delays. And so what is PM2.5? PM2.5 is particulate matter sized to 2.5 microns. It is so fine and granular that it enters your human body without you knowing. It goes down to the deepest layer of your lungs and enters your bloodstream. For my project, focusing on prenatal women, it crosses the placental barrier and actually enters the organs of the fetus. And it's made of, it's like a little cocktail of pretty much all the emissions in the atmosphere combining and chemically eroding each other And so there's a ton of different combustions, most popularly wildfires, combustion of vehicular emissions, etc. All right, so in the past decades, researchers saw spikes in preterm birth rates and decided to study, well, why are these preterm birth rates increasing? Why is infant mortality increasing in our world? And one of the biggest factors was environmental. When they did an analysis of all the chemicals that we are exposed to on a day-to-day basis, they found that pregnant women that were exposed to PM2.5 had substantially higher rates of preterm births than other pregnant women. And so they conducted that study in China originally, and then it came over to the United States in New York. And then my study kind of focuses on California, and the question really now is, where is this happening and why is it happening? What's the source and who is impacted? So those are my research questions. My hypothesis is that fine particulate matter in California causes preterm birth rates in racial ethnic minority communities at a stronger rate than in non-Hispanic white communities, and this can be correlated with direct environmental factors. So my study builds directly upon a study done by my advisor, actually, and so it's a decomposition analysis of Black-white disparities in preterm birth outcomes, and it was able to sort of dissect the differences in the social and structural determinants versus the environmental determinants, and was able to find that in California, there are environmental exposures that pose higher risks for these minority communities than others. All right. So to start, we did a classical mediation analysis, which is an epidemiological analysis that pretty much plugs in these equations that tells us whether one phenomenon is occurring because of another phenomenon. And so we were able to find that PM2.5 does cause preterm births in California, and that Black population specifically, which was our exposure, it is higher for Black populations. And so there's a direct correlation between racial ethnic minorities in California and exposure to PM2.5 at a higher rate, and outcome being the preterm births. So here's an overview of my study area and my study statistics. So this is just a little bit of exactly what I studied. I was able to account for variables like the proportion of like education and income factors, so that it was strictly environmental. The next thing we did was a spatial regression analysis, which used a geographically weighted regression model in R to sort of show where is the correlation between PM2.5 and preterm births highest for Black populations. And this isn't my most updated model, but imagine the middle one, or sorry, the natural indirect effect, the one to the very right, has a lot more red in the Central Valley and Southern California. So I took the composition for PM2.5, and I was able to geocode it into a map to sort of show exactly where it's highest and lowest. Just for reference, the safe exposure, according to my research, safe exposure for prenatal populations is 5 micrograms per cubic meter. And if you look at my map, I'm just going to step away for a second. If you look at my map here, anything darker than the lightest shade of yellow would then be considered unsafe for prenatal populations. And so this is just the average PM2.5 that's in the atmosphere in California. This is the preterm birth rates by zip codes across California. So again, the darker colors correlate to higher potency of the outcome, which is preterm births. And so some zip codes see up to 32% of all births being preterm births, which is really substantial and shows like just how important it is to study this in California because of our unique air pollution conditions. The next analysis I did was a bivariate analysis, which shows where both variables are intense, so the highest at the same time. If you look at the little diamond up here, the darker, what we really care about is the darkest shade of blue. So where is that blue the darkest shade? So you can look at the Central Valley around Fresno and Kern counties, Los Angeles, Sacramento, and the Bay Area. Those were like sort of the highest intense regions for these variables being high at the same time, which just shows like the relationship. The next thing I geocoded was the exposure, so the Black populations, and then the outcomes, so preterm births in Black populations. It's been studied various times before that Latino and Black communities face much higher rates of preterm births and maternal adverse outcomes than do other communities. And so here you can that's just a simple overview. The next analysis was a clusters and outliers analysis, and this really is honing in on the environmental aspect of my research. What you can see here is the peach-colored clusters. Those are where there are high occurring preterm births surrounded by other zip codes with high occurring preterm births. And when they're concentrated so close together, you know that it's an environmental impact. It's not an outlier like for some of the darker red in Northern California. Those can be outliers, those could be due to other sociodemographic factors, but here is really where my research kind of honed in on the environment. And so there's Los Angeles, Fresno, Bakersfield, and a little bit of the Bay Area. All right, so I was able to take all of these analyses and sort of compile together exactly what this all means and the conclusions. The first was the spatial mediation analysis, in which I found the exposure variable to be directly correlated with the outcome variable, with the mediator being PM2.5, so particulate matter 2.5 does cause preterm births in this community specifically. The next was the classical mediation analysis, which shows like exactly how significant the connection is and just establishes correlation. And then the clusters and outliers analysis, which is what I showed you with the different clusters, so the peach-colored zip code tracts, and also the outliers, so like the light blue, the dark red, that kind of just really explicates like the climate aspect of this. So PM2.5 is exactly where the high clusters of preterm births were, so that shows kind of the atmospheric correlation between health outcomes and air pollution. And then the last thing was just the bivariate mapping, so creating maps visualizing the overlap of high PM2.5 exposure and high preterm birth rates. This also helped me highlight the hotspots to go into my interventions and policy, which is coming up next. The hotspots were the San Francisco Bay Area, Central Valley, including Northern Central Valley and Southern Central Valley, and then Los Angeles. So just to go into solutions, because now that we know this is happening in California, we know kind of have an idea of where it's happening, what can be done. And so there's kind of 3 rungs to explore. There's the urban air pollution, so reducing emissions directly at the source. There's the epidemiological solutions, so finding more interventions that are directly related to health and access to health and all of those things for these prenatal women, and then also co-pollution and heat. So PM2.5 is different across California depending on where it is and what is emitting around it. And then heat makes it much worse, so heat makes PM2.5 more potent in the atmosphere. And so my questions really here are, how can we pursue epidemiological climate solutions, and how can we better outcomes for Black and minority maternal health outcomes? So this is a model that shows both precipitation and fire events, which both impact PM2.5's chemistry in the atmosphere. If you look at just like the first time series, there's such a more intense outcome for climate for exactly where I was studying. So the Central Valley, Southern California, and the Bay Area, they all sort of get worse in California, and this is going to just continue to add the importance of whether, so if PM2.5 is unencumbered, it's just gonna have worse and worse outcomes for human populations. And so approaching solutions, I kind of strayed away from individual solutions because prenatal populations are a little bit more nuanced. They're more stationary, they don't move around, and they're also, pregnant women have higher oxidative stress, so asking to mask can be a lot. And so my solutions primarily focused on systemic solutions and regional solutions. So emissions reductions, wildfire prevention, climate adaptation, and then closing the racial ethnic health barriers. So these are the existing regional California climate policies. California does suffer from some of the worst air pollution in the country. Over 5 of the top 10 worst air polluted cities in the country are actually in California. And so California does have its own unique privileges of being able to implement our own California policies. So the first one is just my first region, which is the SF Bay Area. Second is the Central Valley, and the third is Los Angeles. This is based on their specific outcomes for emissions. And so I'm going to dissect exactly what I found in reading all of these and how they can be improved. So the first thing is that they were successful in naming emissions-specific sources. So in the Bay Area, there's a lot of stationary emitters like refineries, factories, etc. In LA, there's a lot of transient pollution, which comes from ports, transportation, etc. And then in the Central Valley, it's mainly dust and agricultural, industrial pollution. And so they do list all the specific emitters in their policies, but they're lacking a lot of language for specifically enhancing health outcomes for their residents, and also talking about the disparities in exposure. And so if there even was mention about disproportionate impacts or unequal burdens, it would be reduced down to one sentence out of like a many page document. And so it's kind of vague. It needs a lot more help in actually defining where the vulnerable neighborhoods and where the vulnerable communities are. And then I'm just gonna go through some of my research limitations because it's important. So the first thing is ambient monitoring and modeled data may not accurately capture individual level exposures because of intra-tract heterogeneity, time activity patterns, and so as a result, non-differential exposure misclassifications can bias affect estimates towards the null. The second thing was residual confounding. So unmeasured confounding is still possible, even though I did account for income and education. There's also spatial statistical limitations. This whole project was about spatial patterns, and so there's other type errors that could come up with that. There's generalizations that I made based on my specific data on Black populations specifically. And then the last thing is just temporal alignment. So exposure obviously is different throughout the pregnancy, whether it's the first, second, or third trimester. And there's seasonal variability in PM2.5. And so there's differential exposure throughout pregnancy to particulate matter in the atmosphere. All right, and then lastly is my acknowledgements. The first person I want to acknowledge is my committee chair, Dr. Tariq Ben Marnia, who sort of helped me kind of hone down what I wanted to research and has been really, really helpful in just being able to explore this and give this topic justice. The second person is my committee advisor, Equin, who's had so much patience with me and has helped me conduct all these really advanced analyses in an accurate and a beneficial and impactful way. And also to my cohort, who always continue to inspire me with their fun and exciting topics, and also my family and roommate. All right, thank you so much.
Thanks, Sharon. That was great. Was there any findings that surprised you?
Yeah, I think I was definitely really surprised at how intense the outcomes were in the Bay Area specifically. So here is like, this is just so intense in PM2.5 and preterm births that that surprised me because I'm from the Central Valley. And then also the just racial segregation that I feel like California, you can see from these maps just how different zip codes can be in their composition of Black populations and minorities, which impacts the exposures and impacts health outcomes. So those were both surprising to me.